Welcome to the Corf tutorials. Today we will show how to size compressors. Let's assume that we have a mixture of propane and butane entering at 150 kilopascals. We receive 120,000 kilograms per hour of material, and we need to deliver the mixture to a destination located 500 meters from the compressor at a pressure of at least 900 kilopascals. As per design guidelines, any control valve on gas service must have at least 40 kilopascals pressure drop. To model this system, we need a compressor, a control valve, one feed, and one product. We will also need specific components for the mixture. Go to the Process menu, then select Components and use the search field to find C3H8, propane, and C4H10, butane. Add each component and click OK to save. Double-click on the first branch segment, L1, and remove the default pipe size to let Corf estimate the proper diameter and change the length to 5 meters. Then go to the Flows tab and specify a flow of 120,000 kilograms per hour. Finally, click on Fluid to specify the mixture. Go to Composition and enter 0.8 mol fraction for propane and 0.2 mol fraction for butane. Click OK to save changes to composition, and again OK to exit the pipe dialog. Double-click on the second branch segment, L2, remove the size and adjust the length to 500 meters. Click OK. Finally, double-click on the last segment, L3. Remove the size and adjust the length to 1 meter. To assume that the pressure control valve is located at the end of the line. Open the compressor dialog and remove the pressure drop. Click OK. Note that when working with compressors, the physical properties from the flowing inlet line can be used, but in general it is better to provide proper vapor phase physical properties for both the inlet and outlet line. As we will be using the H&H balance, Corf would automatically estimate such properties. Otherwise, ensure that you specify the outlet segment properties and composition. Now double-click on the source, F1, and change the pressure to 150 kilopascals. Click OK. Then, go to the product, TK1, and change the pressure to 900 kilopascals. Click OK. Finally, go to the control valve and specify 40 kilopascals for the pressure drop. Move to the Size tab and remove the CV specification. Click OK. Confirm that variables required and specified match. Bottom left corner. And click on the H&H button to run the hydraulic and the heat and mass balance simultaneously. Accept the overwrite warning. After a few iterations, Corf will find a solution for this system. Click on Results to display flow, equipment pressures, and control valve CV. Click OK. Open the compressor, and you will notice that Corf not only estimate the required pressure increase to meet the process requirements, but also the efficiency, the pressure ratio, and the equivalent inlet volumetric flow. Corf also provides the ability to generate typical curves based on the current flow. Go to the second tab on the compressor dialog, Curves, and click on Generate Typical Curve now. Confirm the override warning, and you will notice that Corf provided inputs for flow, head, and efficiency that are consistent with the pressure increase calculated for the system. Please note that shape of the initial curve can be updated if required via the project files. Now let's assume that we would like to know the control valve pressure drop change when the flow is reduced. A simple analysis would suggest that lower flows will result in higher pressure at the compressor outlet, and therefore our control valve required a higher pressure drop to maintain the product pressure. To verify our analysis, go to Hydraulic Cases and change the second case description to minimum. As we didn't change anything from the original simulation, there is no need to run the case 1, so only use 2. Click OK to accept changes. Then double-click on the first pipe, go to the Flows tab, and add 100,000 as flow specification for the second case. Make sure to enter a semicolon to separate each case specification. Click OK. Open the compressor dialog, and in the pressure drop, add a C to instruct CORF to use the generated curve. Once again, ensure that you are adding a semicolon for the first case. Finally, go to the control valve and add a semicolon after the current pressure drop specification to indicate that we want CORF to calculate the drop for the second case. Click OK and rerun the simulation using the H&H button. After a few iterations, CORF will find a solution for the new system. As expected, the reduced flow resulted in higher discharge pressure in the compressor, based on the generated curve, and the control valve almost tripled the pressure drop to maintain the product required pressure. Finally, note that instead of generating a curve, we could copy and paste real values from an actual curve provided by a vendor. Congratulations! Now you know how to calculate compressors, create compressor curves, and use compressor curves in CORF.